right, so this question has asked us to find the vertex of this quadratic function, right? But not just find the vertex, we've also been asked to determine the number of solutions. Now I want you to think about that. Have I asked you to find the actual solutions? No. What have I asked you to find? Number of solutions. Now, if you found what the actual solutions were, and we got methods for that, right? You can still give me the answer, right? Because once you see the solutions, you'll know how many there are. But today we're going to learn about a process that allows us to be able to find the number of solutions without actually going through the process of finding what the solutions are. Because sometimes they're going to come to you and they're going to say, how many roots are there? How many zeros are there? How many x-intercepts are there, right? They're going to ask you, how many times does this parabola cross the x-axis? And so we got methods for that, right? One of the methods for finding out what the solutions are is factoring, right? We could factor, multiply a by c, right? Then find two numbers that multiply to give us a times c, but add to give us b. Those are our D and E. Plug them into our Punnett square, pull out the greatest common factor, set them equal to 0, solve. Boom, we got solutions, right? But we also have another method. What other method do we have? We could also use the quadratic formula. Pull out the a, b, and c, plug it into the quadratic formula, right? Negative b plus or minus the square root of b squared minus 4ac all over 2a. Work it out, get our answer, right? That's the other way. That's a guaranteed answer to get your solutions, right? Because factoring don't always work because sometimes it's hard to find the D and E, the two numbers, right? But then we also got a third method. Last week, what method did we practice all last week? What method did we use? Look at our methods. We got table, graphing, factoring, quadratic formula. What method did we use last week? Graphing. You got something in your ear, booby? You got something in your ear? Oh, okay. We did graphing, right? So graphing is another way, isn't it? Yeah. We can find our vertex. We learned last week to use negative b over 2a, right? Plug those in, get the x of your vertex. And then what do I do once I get the x of my vertex? Plug it in. I love it. Plug it in, and then I get the what? Y of my vertex. Now I got my ordered pair, right? Now from there, can I do my 1a, 3a, 5a? Right? And just keep doing that until I get my parabola, right? So we got these different methods in which we can solve, but we got to remember that when we solve a quadratic function, the goal is to find the solutions. Give me another name for solutions. Roots. What else? Zeros. What is that? X-intercepts. And here's the problem. They're going to give you a question that say, find me the roots. And somebody going to be like, what are they asking me to do? Well, y'all kept telling me the list every time I ask you. But then when I say, find me roots, it's like, what are roots? What are roots? X-intercepts. They're solutions. The reason we solving these things in the first place, right? So our goal here for today is two things. One, let's find this vertex, right? And then two, let's see how many solutions there are without having to actually solve it. Is everybody following me? Yes? All right, so let's go. Let's start with finding the vertex. Talk to me about the vertex. What is a vertex? It's the middle of your parabola. It's the point where your parabola changes direction, right? It is going to be either the lowest point, which is called our minimum, or it's going to be the highest point, which is our maximum, right? So when you look at this parabola, give me some key features. What do you notice? You up or you down? Think about it before you yell it out. Does it you up and you or you down, and how do you know? Yes. It U's up. How do you know that? Because your A is positive too, right? The A is positive, so this thing U's up. Next question, class. Is there going to be a minimum or a maximum? A minimum. How do we know that? Because it U's up. So that means you have a lowest point, not a highest point. Y'all with me? All right. What else can you tell me about this? Because this is standard form. What else can you tell me? You should be able to tell me something else. Yes, but A and B and C, how do they help me? Y-intercept. What's my Y-intercept? It's negative 32. That's your C, right? yes, it gives you your A, B, and C, but why is that important? Because the C is your Y-intercept. It is the point where your parabola A then crosses the Y-axis. Are you all with me? There's something else you can tell me. You can tell me which way this thing is going to shift. Which way is this thing going to shift? Come on, talk to me. How do we know which way it shifts? Does it shift left or does it shift right? What is going to be that horizontal shift? What is that thing that I have to do in order to figure that out? What do? Multiply what? We multiply A and B. Remember, A times B. If A times B is positive, it shifts left. If A times B is negative, it shifts right. Y'all can't forget those things. We learned that early on, right? So if my AB is positive, I know this thing shifts to the left, right? And if AB is negative, then this thing shifts to the right. That means my vertex is going to be sitting to the right of my y-axis. So if we look at ours, what is our A in this problem? 2. What's our B in this problem? 16. A times B, is that going to give me a positive or a negative? Positive. So if that gives me a positive, then which way should my vertex shift? Left. I know that if I have a coordinate plane, the vertex is going to be sitting somewhere on this side, somewhere over here of the y-axis. Are y'all following me? The vertex is going to be sitting, I don't know where it's going to be sitting over here, but it's going to be sitting somewhere on this side. How do I know that? Because A times B was positive. Does that make sense? Why is this important, Ms. Stampley? Because sometimes they're going to give you a graph and they're going to give you a function. They're going to give you something like this and they're going to say, which of these 4 graphs is the right graph? And what you're going to need to see, you're going to need to see that A. Say, oh, that A is positive, so I need one that used up, so you can eliminate the one that used down, right? You're going to see that you got a y-intercept of negative 32. So what does that tell you? That your parabola crosses the y-axis all the way down here at negative 32. So you can eliminate the ones that don't do that. Are you all following me? And then you're going to be able to see that A times B is positive, which means your vertex should be sitting to the left. So if you got any parabolas where a vertex is on the right, what can you do with those parabolas? Cross them out. You can eliminate them because those can't be it, right? So knowing those key features are going to be so important. You got to remember those things, right? What can standard form give me? It gives me my A, which gives me my concavity. How wide, how narrow, right? Up or down, right? What else does it give me? B tells me that there is a shift, but A times B tells me which way it shifts, right? If there is no B, if there is no X term, no B, guess where this thing is sitting? It's sitting right on the y-axis, right? Because it didn't shift left nor what? Right. Right? So if there is no B, if this would have said y equals 2x squared minus 32, is there a B? No. There's an A and there's a C, but there's no B. So what does that tell me? It did not shift. That means it's sitting on the y-axis. And guess where it's sitting on the y-axis at? Negative 32. How do I know that? Because that's the what? Y-intercept. It only can have one. So if that's the y-intercept and there was no shift and I know it's sitting on this, then it's sitting on this at negative 32. Are you following me? Right? But here we do have a shift. How do I know I have a shift? Because I got a B. Now, which way do I shift? I multiply A times B, and if it's positive, I know this thing shifted to the what? Left. Are y'all following me? These are called key features. They're going to give you questions that you don't even have to do no math for. Nothing. It's just understanding what each part represents. And you can pick it out just by looking at it. Because they're going to give you models that if you understand what all these pieces mean, you can just pick, boom, that's the answer. Next problem, boom, that's the answer. Next problem, why? Because I understand what each of those parts mean, so I can eliminate all these other ones. Are y'all following me? Yes? All right. So, are there any questions about what the standard form gives me? Are we all clear? Yes? Yes. All right. So let's talk about this vertex. Tell me, what is the formula that we learned about that tells us how to quickly get our vertex? What do we do? X equals
negative B over 2A.
Excellent. Negative B over 2A. Now, there are some issues with using this formula that I noticed, right? So let me tell you some things you want to make sure you pay attention to. This says negative B Remember I told you when you plugging stuff in, don't do no math the first time. Just plug the information in, okay? So what am I going to do? I'm going to put here equals negative. Why am I putting negative? Because it was already a negative there. Are you with me?
Yes.
And every time you plug a number in, what did I tell you to put that number inside of? Parentheses. So let's do that. Let's put it in parentheses before we do any work. What is my B?
16.
Positive 16. So I'm going to throw a 16 right on in here. I ain't doing no math. I'm just plugging in over 2 times, and I'll plug something else in. What am I plugging in there? 2. Do I plug in 2 squared?
No.
No, just the 2. The A is just this part. Are y'all following? Yes? Now let's keep going. Now, this is a positive 16, but it's a negative out front. What is that really? That's a negative what?
-1.
That's really a negative 1, and negative 1 times 16 gonna give us what?
16.
Negative 16 over, what's 2 times 2? 4. You gotta be careful with these signs, right? And now negative divided by positive is gonna give me a negative, and 16 divided by 4 is 4. Now, here's the in question. Yes, you got this. But do you know what this is? X. What do you mean X? Any X? It's the X of our vertex. And how many coordinates do we need for our vertex? 2. How many do I have? 1. What am I going to do with this one? Plug it into what? Into my original problem. So let's go to our original problem. Let's do just that. We're going to put y equals 2x squared plus 16x minus 32. Miss Stampley, what are you doing? I am looking for my vertex. This thing used up, so I'm looking for my lowest point. What am I going to do to get that lowest point? I'm going to plug in the x of the vertex. What else is this? It's my axis of symmetry. So it's my axis of symmetry is x equals -4. You should immediately write that down. As soon as you get your x of your vertex, go right on and write that axis of symmetry too, because they're going to ask you that, right? And that axis of symmetry is very important. Why? Because it divides your parabola in half. When you find a few points on this side, all you got to do is reflect them onto the other side. Are y'all with me?
Yes.
All right, so now I'm here, and I am trying to find the y of my vertex. I see the x of my vertex. Again, your first line after your function or after your rule should only be substitution. No math, just plugging it in, and everything you plug in, you put in parentheses, right? So we're going to have y equals 2 times what? -4 squared plus 16 times excellent minus 32. Everybody good there?
Yes.
Yes? Now, we're here. We get all the way to this part and we still can make mistakes. What mistake can we make? Not following the order of operations. What does the order of operations tell us to do? Parentheses first. But do I have anything to work in the parentheses? Do I have this to work? No. Is there anything to do in here? And let me show you what I mean. Because you could have something like this inside. This is something to work. Is there anything here to do? No, there's nothing there, right? What about here? Is there anything here to do? No. So parentheses out, because we don't really have parentheses. Those parentheses mean multiplication, right? So what's next? We got P, then we got what? We got exponents. Do I have any exponents?
Yes.
Do that first. So let me ask you this. Should I go 2 times -4?
No.
No. That's doing multiplication before you do exponents. So grab your calculator. What should we put inside this thing?
-4 squared.
We're going to put -4 and then do what with it?
Squared.
We're going to square it. Right? How many got all of this thus far? Nobody?
Yes.
All of us. Okay. So let's go. What we got? We got -4. So we're going to put 4 plus or minus.
And square.
And then we're going to hit that square key. And we're going to get what?
16.
Now what am I going to do with that?
Multiply by 2.
Multiply by 2. Times 2 equals. What do we get?
32.
So my next line going to say y equals 32. I'm stopping there. Do I bring down this plus sign because there's a plus sign? No, we don't do that. What we have to do? We have to do multiplication next, right? So what am I putting in my calculator?
16
times
-4.
4 plus or minus equals. What do we get?
-64.
So now I'm going to put a sign. Minus, yes, 64 and bring down my what?
32.
What kind of 32? Negative 32. Now we go back over here to our handy dandy calculator. What are we going to put in?
32.
32.
Minus
minus
64.
64
Minus.
minus 32. Do I put in minus negative 32?
No.
No, that's not a double negative. Just minus one time, 32 equals.
Negative 64.
So y equals negative 64. Now let me ask a question. Is that my solution?
No.
No. What is that?
The Y.
The y of my vertex. So do I now have my whole vertex?
Yes.
Yes. And what is it going to be?
Negative 4, negative 6.
Very good. Y'all clap it out for Guido. Guido. He got it right. Are there any questions on this?
No.
Any questions? Raise your hand if you got it right. Good. Raise your hand if you got it wrong, but you understood what your mistake was. Good. Good. Very good. Is everybody good here? Now, what have we just found? We have just found the vertex. Now, Ms. Stampley, how can I use that vertex for something else? Watch this. Almost all these questions that you're going to get on quadratic going to be about key features. Which means you're not going to have to do a whole lot of math. They're going to give you something, and once you get it, they're going to ask you a question, and you should be able to just look at it and get the answer, right? What does this help me with? What does negative 4, negative 64 tell me? Yeah, it's my vertex, but what does it tell me? It gives me my axis of symmetry, x equals negative 4, right? What else? Does this give me my x-intercepts? No. Is this even your x-intercepts? This is your vertex, right? What are your x-intercepts? Solutions. Here's a question. Should I add these two together and divide by 2?
No.
No. Somebody knows that they should add two numbers together and divide by 2 to get something, but they don't know what it is. We already got it. You do that to get the what? Vertex. But we already got the what? Vertex. And what are you adding together and dividing by 2?
The solution.
The solutions, not the x and y of the vertex, right? So we got to know what we're doing and why we're doing it. So we got this. Here's what this gives you. It also gives you your transformation. It also gives you your shift. It gives you your horizontal shift and your vertical shift. Think about what I just said. It gives you your horizontal shift and your vertical shift in one. Remember how we said this thing shifts?
Yeah.
Which direction did we say it would go?
Left.
Left. What in here is evidence that it goes left? That negative 4. Absolutely. Think about it. Doesn't the negative 4 represent the x?
Yeah.
If I'm on 0, 0, the origin, tell me what to do to get to negative 4,
Left.
negative 64.
Left.
Left what?
4 times.
4. I just went left. My vertex just shifted left. And then I'm going to do what?
Go down.
Down what? 64. So when I ask you what is my transformation or my translation or what is my shift, you're going to tell me left 4, down what? 64. That's it. That's it. Yes. You would absolutely be in quadrant 3. Excellent observation. You would be in quadrant 3. Do we all realize that?
Yeah.
Now, I want to take you a step further. Thank you, Aiden, for bringing that up. If you're in quadrant 3, great job. Y'all clap it out for Aiden. If you're in quadrant 3, we're in quadrant 3, right? We went left and down. Our parabola use up or use down? Up. So where's the x-axis in relation to the vertex? Is it above it or below it? Where's the x-axis?
Above.
Above it. If it's in the third quadrant, the x-axis is up here, right? So if it use up, how many times is it going to hit the x-axis? 2. What if the A was negative? It would U down. Then what? It wouldn't hit no x-axis, which means what?
No solution.
There's no solution. If the vertex is below the x-axis already and it used down, if the y and the A is negative, then this thing is not going to have any solutions. Why? Because it's already going to be down here and it's going to go down like this, which means it's not going to hit the x-axis, which means it's going to have no solutions. Does that make sense? Yes? I'm trying to get y'all to picture this and make sense of it. Does this make sense? Yes? Are we all good here with the vertex question? Yes. Now, let's move a step further. Let's answer the second part of this question. The second part of this question is determine the what? Not the roots.
What is the variable?
The number of roots. What are my possible outcomes? How many times can I hit the x-axis? 2. I could hit it once, or I can hit it none. Are y'all following me? Right? So I'm looking to see whether or not I get 2 solutions, 1 solution, or no solution. Then Stampley, can't I just use the quadratic formula and see what I get? You absolutely can. Right? Can I just factor this and see what I get? You absolutely can. But I'm telling you, there is a cheat code. Here's the cheat code. To find the number of solutions, not the actual solution. Not the actual solution. We're looking for the number of solutions. You can use what is called the discriminant. Draw a squiggly in your notebook, and let's start with the discriminant. What is this discriminant? So, tell me where have you seen this? Quadratic what? Formula, right? Stabler, why are you showing me the quadratic formula? Because I want you to see the discriminant. Ms. Stampley, what if I forget? Where can you go? You could go on the wall. What if you taken a test? On your reference sheet, right? So this is why I want you to see this, because I want you to see where it is. So this is called the discriminant. Why is that important? Now I want you to think about what we talked about the other day. How do I find the x of the vertex? Negative b over what? 2a, right? That's part of the discriminant. That's part of the quadratic formula. Ms. Stampley, how do I find out how many solutions? Not what the solutions are, but how many solutions. I'm going to use this piece right here, which is called a discriminant. Are y'all with me? So here's what I want you to write. D equals. What does D stand for? Discriminant. D equals b squared minus 4ac. That's it. How this going to help me, Ms. Stampley? It's going to help you because when they ask you how many solutions are there, you're going to quickly plug your A, B, and C into this little shortcut. And when you do that, based off what it gives you out, you're going to know, oh, this parabola hits the x-axis twice. This parabola hits the x-axis 1 time. This parabola don't hit the x-axis at all. So let me give you your ledger so we know what we're looking at. And then I'm going to explain the ledger so that it makes sense. So here's the ledger. If my discriminant is greater than 0, what kind of number is it? Absolutely. What kind of number is it if it's greater than 0? Gotta be positive. Then I am going to have 2 solutions. If my discriminant comes out to be a number that is greater than 0, I am going to have 2 solutions. I'm explaining why that makes sense, okay? Now, what if my discriminant is equal to 0? That's going to be a 0. That's going to be 1 solution. And what if my discriminant comes out to be a number that's less than 0? Well, what kind of numbers are less than 0? Negatives. So then, only one left, y'all, is going to be no solution. Miss Anthony. Wow. So let's talk about this. Let's say we plug in our A, B, and C and all that stuff up here. Y'all with me? And it comes out to be, let's say, 5 plus or minus the square root of something. Are y'all with me? Is everybody following?
Yes.
Give me any positive number.
7.
7. So watch this. Do I know the square root of 7? No, I don't. But guess what I do know? I know that whatever that number is, if I take a 5 and add it to it, that's going to give me one thing. And if I take a 5 and subtract that number, that's going to give me something different. Is it going to give you the same thing or two different things? Two different things. Matter of fact, let's look at something like this that you can better relate to. Let's say I gave you the square root of 49. That's a positive number, right? Okay, work with me. What's the square root of 49? 7. What's 5 plus 7?
11.
What's 5 plus 7? 12. What's 5 minus 7? Question, did you get one answer, two answers, or no answer? Two. Why did you get two different answers? Because you did what? You added it and then you did what? So if you add this number, it don't even matter what this number is. If this is a positive number that you're going to get out of here, if you add that number, you're going to get one answer. If you subtract that number from that, you're going to get a different answer. So you're going to end up with how many solutions? I don't know what they are, but I know you're going to end up with two different solutions. Let me give you an example of what I'm talking about, China, because I see your face. 5 plus or minus 7. Y'all agree this is what this would be? Yes? I would have 5 plus 7, right? And then I would have what?
5
minus 7. All over 2a, but I'm going to have this part, right? So this is going to give me a 12. This is going to give me a negative 2. I end up with how many different answers? 2. So if the number in here is positive, I don't care if it's a decimal, a whole number. It don't matter. If the number in here is positive, it could have been 49.45. I don't know the square root of that. But what I do know is that if I add 5 to it, I'm going to get one number. And if I subtract this from 5, I'm going to get a different number. So I'm going to end up with two different solutions. Are y'all following me? Yeah. So if your discriminant, whatever is in here, which is this part, which is this part, whatever's in here, if it's positive, you're going to have how many solutions? 2. Y'all don't sound sure. How many solutions you going to have if you got a number in here that's positive? 2 solutions. Are y'all with me? Does that make sense? Let's just do it for fun. In your calculator. Put 49.45. Hit the square root key. Not the square key, the square root key. What do we get? 7.03. Okay, dot, 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 right? It's more numbers, right? Because it's irrational. So watch this. Won't you have this? 5 plus or minus 7.03? So then you're going to have 5 plus 7.03. Then you're going to have 5 minus 7.03. Are we going to end up with two different answers? Yeah. Which means we got two different solutions. Are y'all following me? This parabola is going to hit the x-axis in two different places. Are y'all with me? Yeah. Yes? Ethan, this is important, baby. All right. So now, let me explain the 0. What if we had, let's do the same thing, 5 plus or minus, square root. But let's say your discriminant was 0. Think about that. What if what was in here, your discriminant, came out to be 0? You're going to have one solution. We know that because we put it up here, but why? Because watch this. What is the square root of 0? 0, because 0 times 0 is 0. So you're going to end up with 5 plus 0 and what? 5 minus 0. What's 5 plus 0? 5. What's 5 minus 0? Are you getting two different answers or the same thing? Same thing. So how many answers do you actually have? 1. So if your discriminant comes out to be a 0 inside, Anaya, then that means you're going to have how many solutions, people? Only 1. Why? Because to add 0 and take 0 away is still going to give you the same thing twice. Does that make sense? Adding 0 and taking away 0 does not change your amount. Are you all following me? So what if my discriminant is positive? How many solutions am I going to have? 2. What if my discriminant is 0? How many solutions am I going to have? 1. Because they're going to come out to be the same thing twice. So that means we only really have one solution. Are y'all following? Yes? All right, last one. Let's look at this negative. What if I have 5 plus or minus the square root of, let's say, a negative discriminant? All right? So here we go. Let's just do the problem. Grab your calculators. What are we putting inside the calculator?
Negative 49.
You put 49, hit plus or minus, and then hit the square root key. What do we get?
Error.
What? Figure it out. You did something wrong. Let's do it again. What are we putting inside the calculator?
Negative 49.
We're going to put 49 plus or minus, and hit the, y'all hitting the square root key, right?
Yes.
Square root, what do we get?
Error.
Why are we getting an error?
But there's no
Huh?
Because you can't square root.
Is it a thing?
Oh, you can't square root the negative.
But yeah, I just told you that in the error. But how you know that? What is the square root of negative 49? 7 times 7 is positive 49. What's the square root of negative 49? Negative 7? What's negative 7 times negative 7? What's a negative times a negative? Positive. So, what number can you multiply by itself and it give you a negative? Can't. It would have to be a positive and a negative. But then would it be a square root? No, because square root has to be the same number. And positive 7 is 14 spaces away from negative 7. They two different numbers. Are y'all following me? So here's the idea. Can you really take the square root of a negative number? You can't. So if what's under here is negative and you're going to get an error, guess how many solutions you got? None. So let's go back and look at that again. If I have a positive number under here, how many different outcomes can I get? 2. I'm going to add something, get one number, subtract that same thing, get something different. Right? But what if what's under here is a 0? Only one solution, because to add 0 and take away 0, does that change your value? No, so it's going to be the same thing. But now what if that number under here is a negative? Why is it no solution? Because what? It would have to be 2 different numbers. Your roots would have to be different in order for you to get this negative 49, different signs. And there's no way you can do that, right? Square root says I need the same number. They either both going to be positive or they both going to be negative. And either way, when you multiply them, they're going to come out to be positive. Are you with me? So if I got a negative radical, if I got a negative square root, I can just look at that thing and be like, ooh, no solution. So when they give you a problem, and then you're looking at your choices, and one of them say no solution, guess what you can do? Let me go through this discriminant real quick. And let me see, because if that radical come out to be negative, yeah, no solution. Moving on. Are y'all with me?
Yeah.
Are you following? Yes? All right, so we got to understand these key features. So knowing that now, let's go to our problem from today. What is our problem for today? Y equals
2x squared plus 16x negative 32.
Oh, y'all are great in core and just in choral. Y'all just great in responding all together. I love it. Do it again. What was it?
Y equals 2x squared plus 16x minus 32.
Okay. All right. What's my A? What's my A? 2. What's my B?
16.
16. And what's my C?
Negative 32.
Negative. Don't forget your signs. Negative 32. Now, let's use this discriminant to see how many solutions, not what the solutions are, but how many solutions we're going to get, right? So we're going to put discriminant equals B squared minus 4AC. Right? All right, so we got what? D equals. What's my B?
16.
I'm plugging it into a parenthesis. Remember? Squared. Y'all with me?
Yes.
Minus 4 times. What's my A? 2 times C. What's my C?
Negative 32.
Negative 32. Don't skip steps. Don't look for shortcuts. I'd rather you take the regular way and get the answer right than to skip something and get it wrong. So D equals. We got exponents, we got subtraction, we got multiplication. What we going to do first? Exponents. You got the calculator. What do I put in here? 16 squared. What do we get?
256.
256. Now, do I drop this negative?
No.
Never. What do I need to put in the calculator? And let me model that for you real quick. What am I putting in the calculator? 4 negative. Then what? Times 2 times 32 plus or minus equals. What do I get?
256.
Now, what kind of 256 is that? So what am I going to put? Plus 256. If you put a minus there, that's going to say minus 256. Then you're going to end up with 0, and you're going to get it wrong, right? That 256 is positive. A negative and another negative is a positive. So now what do we end up with? It don't really matter. This is 512. Does that mean I got 512 solutions?
No.
No. Can you imagine that? The parabola hitting the x-axis 512 times? I ain't got time to count that. What does this mean? What kind of discriminant do we have? Positive, negative, or 0? Positive, which means what? Two solutions. That means this is going to hit the x-axis twice. But we knew that. Why? Because Aiden told us our vertex is sitting in the third quadrant and is U-ing up. So it's going to hit that x-axis twice. But we already knew that. Are y'all following me? Everybody good here? Yes? All right. Any questions? No. Let's stop that.